Ah, very good. Yeah, you guys got square root of 58. That is perfect. Okay. Let me unfreeze the screen now. I do apologize. My recorder just stopped for a second, so it's kind of annoying. But it's still going right now. So let's see. Let's see if I can make this a little bit bigger. Okay. Did everybody see that? Yeah. Okay. So I have to kind of do it like this because I think every time I make it full screen, it kind of stops the video. So I don't know what's going on. But okay, let's go on. So we are now moving on to, so you guys found out that this is, I think you guys did 7 squared plus 3 squared is equal to the diameter squared. Then you did 49 plus 9 is equal to d squared. Then you got 58 is equal to d squared. You square root both sides. So you found that the diameter is 58. So this whole thing is 58 square root, and then you took the circumference, which is d times pi. You should have gone square root of 58 times pi. Okay, so you don't have to write that, but just for people taking notes after. Okay. So now let us move on to 11-2. 11-2, measuring angles and arcs. Sorry, with one A-R-C. Sorry, A-R-C. A-R-C. Fun trivia. That took me like 3 years to roll my R's. Because, yeah. So, a good friend of mine, okay, very, very close friend of mine, speaks Spanish. And she always wanted to roll my R's. And, I started with, and after 3 years, still can't do it. Yeah. Still makes fun of me. Okay. All right. So the first thing we're going to do is sum of central angles. Before we do this theorem really quick, let's describe what a central angle is compared to an inscribed angle. So this is a central angle. So angle 1, like that's angle 1 right there, right? And then this is an inscribed angle. It's just a little debriefer here, inscribed angle. We'll call that angle 2. What's the difference? What do you guys notice is the difference between a central angle and an inscribed angle? What's the difference?
It goes to the midpoint, or the center.
Yeah, it goes to the center. Get it? Center angle is, same, it just starts from the center. An inscribed angle means that your end points, okay? I say end points. So in case you don't know, these are end points. Endpoints. In fact, this is still technically an endpoint as well. All these are endpoints. Endpoints are just where your lines stop. Endpoint. You kind of get the idea now, right? A central angle is where the endpoint is in the middle. And then the other two endpoints are on the circle. On an inscribed angle, all the endpoints are on the circle. Does that make sense? Is this on the circle? Is this endpoint on the circle? Yes or no? No, it's not. But an inscribed angle, all the endpoints that make up the angle are on the circle. So that's the difference, okay? Here's what they should come out to. Can anybody tell me how big that angle is? Can't really do it, huh? Not by just eye. Does anybody know how to use a protractor? Did I show you how to use one, kind of? Well, I'll show you now. Kind of hard to see, but if I can, I'm supposed to line up the circle here. So you know what? Keep your circle here, okay? I'm just going to draw a blown up version, okay? Okay, so don't draw a big circle on your paper. I just want you can do this on the same one. So let's say that this is the angle right here. Okay. So let's see. You're supposed to line up this line to the ruler, and then you just connect this guy and overlap them right where your second line is. So that is about like right here. How many degrees are we looking at? And then let's see. This is 0 degrees, 10 degrees, 20 degrees, 30 degrees, 40 degrees. How many degrees are we looking at? 55, right? Yeah? Okay, so you can write that in yours. Go ahead. And let's draw another angle. So let me draw another one from here to, why don't we draw, how many do we want to draw up to, guys? Do you guys see my protractor? We're on 80 right now. Do you see that? We're on 80 degrees. How far up do you want to go up to?
270.
Do you want to, please don't do that. How about less than that? Mr. Wee's really lazy. I'll say this. You can go up to 180, wherever you want to go.
15.
Oh, that's very nice. Okay, so we'll go to 15. Okay. So now I just got to draw in a line. That's 15 degrees, right? Okay, and how about one more? No, a little bit bigger than 2. Okay, how about much bigger than 2? But less than 180. Sorry, it's so constraining. Alina, you pick. Give me a number. 90? Oh, thank you. That's a good round number, unlike some people. No, I'm just kidding. Just kidding. Okay, so let's say it's 90 degrees. Oops, sorry. That's not pretty, but that's about 90 degrees. Okay, should come from this the center, the point there. Okay, that's 90. And I will tell you this: if I measured the rest, look at this. Sorry about that. This is 200 degrees. If I measured this, okay, meaning if I did it from here, this is kind of difficult. So here, it would break my protractor. So that's, you see how it goes to complete 180, right? And let's say, actually, let's just do that. Why don't we just add one more line? Let's say that's 180 degrees. So let's say, let's scratch it. This is 180 degrees, okay? And then this over here should be about 20 degrees. So, sorry, this over here should be, yeah, look at that. It's about 20. Yeah, it's not. Let me see. Okay, but, all right, I don't know if we're doing this right. Where's the center? There's the point there. Okay, Mr. We didn't draw this too perfectly, but it was supposed to go up to 220 degrees. So my apologies. Okay, so let's write in those values: 180, 20 degrees, 55 degrees, 15 degrees, and 90 degrees. Let's see how much they add up to. How much do you think it'll add up to? So let's do that. 180 plus 20 plus 55 degrees plus 15 degrees and 90 degrees. Was it 20? Or did I get 30? Sorry. It's about here. So I think it's about 30. Sorry. I think that is it 30? No, sorry guys, that's 30 degrees. Sorry. This one is 30. Yeah, it was 30. Sorry. Mr. Reeves, kind of crazy. That's 30 degrees right here. Sorry. So change that to 30. What should you guys get here? It's 12.
I think it would actually be 20.
Oh, was it 20?
Mathematically, but I don't think how many protractor was.
Yes, 360.
Yeah, if you do 30.
Sorry. Change it back to 20. Okay. So what I'm trying to say is this: the sum of the central angles. I kind of manipulated it. All right, I'm not gonna lie. I'm sorry. If I do this a little bit more perfectly, it should go to theorem. Okay. Going back to your notes, or if this is on your notes. Okay. the sum of all your central angles. Central angles. That's angles. This is angles, okay? Angle sign with an apostrophe S. Sum of all central angles is 360 degrees on any circle. Well, except for the ones that aren't drawn well, but at that point we wouldn't call it a circle. A circle has to be as what it like sounds like. It's circular, okay? It's 360 degrees. Any. So if I put this into like a million different central angles, right? Don't draw this, but I do this. Boom, 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 boom. No matter how many angles I make, they're all still going to add up to 360 degrees. Okay? It's the name of the game for a circle, right? If I gave you this angle here, could you tell me what x would be? You could do a little bit of math on your paper if you want. What would x be?
140. That's also right there. Just about.
Don't.
Because like 220 subtracted from 360.
Okay, Zane, how on earth did you get 220?
Because 90 plus 130.
So where's the 90 degree angle, sir?
The box.
Okay, in the box right here, this indicates this is 90 degrees. This is 130. You add 130 and 90, and you subtract it from 360, and then you should get 140. Does that make sense? This is your first example in the book, if you need to know. So if you didn't quite get that, please write in there. The answer should be 140. Okay? Does that make sense? That's pretty simple math. But what you don't know are these things called arcs. Remember, the name of this section is measuring angles, which you already get, but you have to measure arcs as well. Okay, without looking at the definition, what is an arc? What is it pointing to on the circle?
This is between two lines.
This is between two, like where? What two lines are you talking about?
RQP.
Does everybody see this arc here? Yeah? And this is an arc here? Well, it says an arc is a portion of a circle defined by two endpoints, okay? So the endpoint here, P, and the endpoint here, R, make up this arc. Does that make sense? And yeah, I would just leave it at that. And then let's go ahead and look at the three different types of arcs. How would you describe these three arcs? This is called a minor, this is called a major arc, and this is called a semicircle. How would you describe these three arcs? It's in red. That's the arc is in the red. Which one is the biggest arc? This is the major, this is the minor, and this is the semicircle. Which one is the biggest? Minor, major, or the semicircle?
Major.
Do you guys see how the major is the biggest? Easily, right? It's like from here to here. This one's going to be the smallest, and this is half the circle. Well, if you are greater than 180 degrees, or actually, let's look here. If you're exactly 180 degrees, a straight line and an arc, you are a semicircle. Get it? Because you're half the circle. If you're anything less than that, you are a minor arc. If you're anything more than 180 degrees, meaning you're way past these 2 points here, okay, you're a major arc, right? So let's see. And one more thing. So let me give you a quick example here. Arcs and angles. So please, central angles. So let me write that, central angles. Central angles. So write this in your notes, please. If you want to talk about the arc, you see the arc here? If you have, this is an arc, and we'll say that it's defined by two midpoints A and B. All right? Does everybody get that? A and B. Does everybody see that? The arc the measure of the arc, the measure of the arc AB, that's how you write arcs, AB, is exactly equal to the central angle, the measure of the central angle. So an example again. Let's say that same circle, let's try to make the same exact circle. If that is 30 degrees, measure of arc or measure of angle 1 is 30 degrees. And then let's say this is A and B. Can you guess what the measure of the arc is going to be equal to? It's the same thing. It again is 30 degrees. Does that make sense? You don't need to write this part down, but let's try to do this by eye. Or actually, maybe we do need to do this one. I think this one is worth going for. Oh, that's sorry. My apologies. Thank you. Okay. So if we had an example here, here's an example. If you have a circle, and this is given to you as G, J, the middle point is K, goes out to H, and this is 122 degrees, right? And I also know that GJ, the line segment GJ, is the diameter. The diameter of circle F, or K. Sorry, K. It's right here. Circle K. Then you must identify each arc and find its degree measure or measure, right? So let's look at the first one. The first question is HJ. What kind of arc is that? Or actually, no, let's not do HJ. Let's do something even easier. GJ. L. You guys see draw in point L right there, okay? Does anybody know why I have a point GLJ? Why is that significant to have GLJ? Why don't I just write that as GJ? Why can't I just write G to J?
Because then that means that's the diameter.
Well, it is the diameter. That's what I want. I want
Not the arc.
Well, I want the arc GLJ. Yeah, that's true. But how come I didn't write GL? How come I wrote GLJ? How come I had to have that one over here? Does anybody see the significance in why?
So it goes through L instead of K.
It goes through L. Well, I don't know which way you're talking about. Are you talking about GJ this way or GJ this way? Do you see what I mean? If you have the L there, it'll tell you, I want you to go from here to here to here. I want this arc on the bottom, okay? All right, what kind of arc is that? Is that a semicircle? Is that a major arc or is that a minor arc? Which one is it? What do you got, Alexis? And then how many degrees should that be? Yep, very good. And then how about the next one, HJ? What kind of arc is that? Minor, thank you. And then how would you solve for that?
Subtract 122 from 180.
Oh, from 180. Oh, I see, because you said this is 180 and you think this is 1. Okay, right? So what I'm going to do is I'm going to take the whole circle and then subtract the 180 from GLJ 22 to find HJ. The measure of HJ. So what is 360 minus 180 minus 122? You can plug that into your calculator for quick. That is 58 degrees. Is that less than 180? 58? Yes, it is. So that is not a major arc. That is a minor arc. Question for you. What kind of arc is GH? Oh, my. Minor. Oh, yeah, I'm sorry. No, you're right. You're right. It is minor arc. Yes. Yeah. Major is where it's bigger than the whole thing, right? Okay. If it's bigger than 180 degrees. All right. Great job. There's some of the work if you need. Okay. And let's move on. Let's see. Do you guys want to try one now? Just on your own or no? Is it too easy? You guys want me to move on to like a harder problem to go through? Yeah? Okay, so because we still have about 10 more minutes of class. So let me go through something that I think will be helpful to you. So you found everything in degrees, right? Not a big deal. So what if we gave you a problem where, let's see, you find the arc length. Oh, cruddy. So what if you found the arc length? So let me give you an example of what arc length means. What if I gave you this, and I said find the length of zy, the arc, okay? That's the length zy. And then here I give you a huge circle. I give you the center point x, and then I give you z is right here. Z is the endpoint right here. Y is the other endpoint right here. Then I give you that this is 4 inches. That's the radius. And I want you to find, or I give you 75 degrees for the central angle measure. But I want you to find the length of CY. Oh, crud. I don't know what that means. The length, meaning I don't want you to find the angle measure. Oh, what is the angle measure of ZY then? Angle measure. What is the angle measure of ZY, the arc of ZY?
75.
We know that's 75, right? So we know that the arc ZY is equal to 75 degrees, right? I got that, right? This is 75 degrees in here. That means that's 75 degrees out there, right? But how long is it with a ruler? Oh, man, I don't know, okay? So here's what you're going to do. You're going to find a proportion. You're going to set up a ratio, all right? This is 75 degrees, right? This is 75 degrees. And let's compare it to the whole circle. This is 75 degrees over how big is the circle in terms of degrees all the way around once? 360, right? Well, what I can do is I can also compare it to maybe, let's say, the length of the circle. I might not find the length of the arc, but can I find the length of the whole circle? What is that called? That's called the circumference, right? So I'll set up a ratio with the circumference on the bottom, and then I'll leave this one as x. That's what I don't know what the length is. I don't know what the length of this is in inches, right? So I'm going to set this up. I don't know what this is, but I know that I can compare 360 degrees to the circumference, right? The circumference would be, how would you calculate the circumference? Circumference would be, I'll write it off to the side here, would be like 2 times 2 pi r. What is my radius, by the way? What is the radius on this circle, my friends? What? The radius. The 4 inches, yeah. The actual length, 4 inches. That would be 8 pi, and you could say inches, okay? That's 2 pi times 4. So that gives me a circumference of 8 pi, right? So this is 8 pi. Now what can I do to solve for x? You just cross multiply. So you get 360x. And help me out here, Zane. What is 8 times 75? On the calculator. I asked you because you have the calculator. Not because I want you to test your math in public.
600.
600?
Yeah.
600 pi, okay? Then divide both sides by 360, okay? Let me model this for you. So write 600 pi, Zane, in your calculator, divided by 360. 600 times pi first, divided by 300. And then did you divide it by 360 after that? Okay, and what'd you get?
5.23.
Yeah, you're absolutely right. So x is equal to 5.23. That's not bad.
Would
So-
you rather us multiply in the pi or just leave it?
You can leave the pi in there. So some people are like, why don't I just divide 600 divided by 360 and then simplify that and then just leave the pi in there at the end. You could do that too. Or you could put it all in the calculator. Some people just want to get done with it all the way, okay? So in case you don't know what I just did, here's what you're supposed to do, okay? You take you take degrees here. So actually, let me see. How can I do this? You're gonna take, let me the general form. Here's the general formula, okay? So let me give you the circle for what you just did. Let's say that that's x degrees, okay? This is the length L. L stands for length. R is radius. You know that's R radius. So in the future, what you did was you took x degrees divided by, so whatever the degree was, divided by 360 degrees. You set that equal to the length, which you don't know, divided by the circumference. Does that make sense? And the circumference, in case you don't remember, is 2 pi r. That's what you just did. Does that make sense? I would want to give you guys some time to do an example, but class is about over in 2 minutes. You guys want to try one still, or do you guys want to just call it a day? What do you guys feel like doing? It's up to you. You just want to call it a day? Okay, all right. Fair enough. Okay. So come in and see me if you need, okay? I want to get through these two sections. I'll put up 11. I guess I have to put up a video for 11-3.